Is Omar Zaro, and this is my presentation on capacitors in automobile sound systems. What is a capacitor? A capacitor is a device used to store electrical energy in form of electrostatic field between two plates. It is similar to a battery, but batteries is an electric device that converts chemical energy into electrical energy to create power. A capacitor are mainly used for electrical devices that are commonly used for local energy storage, voltage spike suppression, and complex signal filtering. Some examples of capacitors in our everyday lives are pacemakers, cell phones, computers, and almost any electrical device with an electrical circuit. In the bottom right, you can see a picture of a capacitor. You can see the capacitor's rated value on its side in microfarads and the voltage in which the max value in the capacitor can handle in voltage. What's inside a capacitor? A capacitor are made of two electric conductors separated by some type of material. The space between the capacitor could be either a vacuum or filled with some insulating material known as a dielectric. Some examples can be glass, ceramic, plastic film, um, air, paper, and etc. Depending on the shape and size of a capacitor plate, it can hold a certain amount of charge known as a capacitancy, and we denote it as C. We worked with this almost a whole semester, um, and we measure capacitancy in farads F. Over here to the left, I have an example of what a capacitor looks like inside. You can see there's two terminals and they're separated by some type of dielectric. It could be any insulating material, so the two terminals aren't touching. You can see when they're connected to a battery, there's a buildup of positive and negative charges, and that's what makes the electric field attraction between inside the capacitor. Um, Over here to the right, I have images of some common uses of capacitors. Um, these it could be used for almost any electrical devices down here, whatever your system actually needs. And on top, we have some examples of construction symbols and terminal identification of capacitors. Physical principles of capacitors. The capacitancy C of a capacitor is defined as the ratio of the maximum charge Q that can be stored in the capacitor to the applied voltage V across its plates. We use the equation C equals Q divided by V to find the capacitancy. Uh, we can also switch up the equation to find the charge in the capacitancy by using equation Q equals C times V. Um, Energy stored in a capacitor can be also be found by using the equation right here. Uc equals to 1 half V squared times C. There are different types of capacitors. One example is a parallel plate capacitor, and again the equation is C equals Q divided by V, or permittivity of free space times A divided by D, where A is the surface area A and D is the distance between the two plates within a capacitor. Capacitors have different value ranges. We can have picofarads, millifarads, and microfarads. And some of the symbols for capacitors are fixed capacitors, polarized capacitors, and variable capacitors. The different types of capacitors. We have three different types of different capacitors. We have the parallel plates that we covered earlier, the spherical capacitors, and the cylindrical capacitors. And the equations below are the how do you find the capacitancy for each capacitor. We also have capacitors in series and in parallel. Um, we can find the sum of the capacitancy for series by using the equation to the right, and to find the capacitancy for parallel, we'd basically just add up all the capacitancy to get the net capacitancy. How does capacitor relate to sound systems? I have worked on sound systems before, and from my own experience, when you're adding many aftermarket components into a vehicle and it starts straining power from the actual car, um, you tend to see some problems pop up, like either the sound system isn't working properly, where speakers are blowing out, or amplifiers aren't working properly, or even some of the car components like the ECM and the ECU start throwing codes, and just all this is because there's a low low voltage in the system, which can cause more problems in the future for you. And it's always good to have a certain amount of voltage in the system, regardless of if you have a upgraded sound system or not. It's always good practice to have the correct amount of factory voltage in the vehicle. Automotive capacitors. There are different rating capacitors that are used in sound system. Usually you don't really need a capacitor if you're adding small stuff like speakers or a new radio. But if you're adding some more components, like you're upgrading the speakers from like 6 ohms to 2 ohms, or you're adding subwoofers which are around like 8 ohms each, and then an amplifier, and all these components will take power. Usually, you would need the car to consistently have a certain amount of voltage. The battery has around 12 volts. When started, it should have roughly from 13 to 14 volts, and it will fluctuate just a little bit depending on what's being used inside the vehicle. So that's why we use components like capacitors to help keep voltages in a vehicle at a certain voltage. And down here, I have given you kind of like an example of what to expect when you're adding like an 8 ohm speaker, which at full power will give you roughly around 20 volts, and you don't want to pull that much power from the vehicle again. Um, and a second example, that two 8 ohm woofers in a series, you can see it takes 24 watts, and again, it will drain your battery eventually if you don't have a capacitor.